Hello, everyone. I hope you can hear me. All good? Okay. Even closer? Okay. So, okay. So I'm Prajwal. So here I'm talking to about MCP and A2A, but if you don't know yet, but you would, after 20 minutes, probably you would know it better. These are the two technologies which were last year discovered by the AI group community, and then I'm here to discuss about it. And a little bit more about me. So I have my master's degree in Master of Data Science at Frankfurt University, and then I also worked a lot of students' job at FEB Automotive, Evonik as a data scientist, and also at Bosch doing more of cloud stuff. But from 3 years now, I work at BMW as a machine learning engineer, more focused on generative AI and data science. And why are we here is basically because another data scientist colleague of mine at BMW, I don't know where Habu is, mentioned it's a very a nice place to discuss new topics and get feedback from the other data scientists or more involved in the data science and AI community. So less about me now and more about the topic. So as you know, the GenAI started somewhere in 2019. And then there was a huge spike, as you know, with the ChatGPT, that ChatGPT can do everything, but not really, that did not happen in 2019 for sure. It could just write you code or just write you poems or whatever, but not really with respect to industrializing AI into different use cases. And then after some point, definitely it got some maturity. Basically now, after some point, you could add like tools. So what does tools means that you could now instruct at ChatGPT saying, hey, if you need any calculation, you could have like a calculator tool. Or if you want to interact with the database, then this is my database, this is how you can access my database, and things like this. So it got a bit more structured and also better at doing tasks and also applying into different use cases. And then now we need a standard protocol. That's why we're talking about MCP right now, because you could do a lot of things with tools, but as you know, there are different AI services, and it's quite huge. So every AI developer at different industry thinks he's the best, but that really depends. And he still has to have the motivation because he should be the best. But as you know, there are a lot of AI services. For example, now you want to create a RAG database. What does that mean? You have a set of documents, and then you want to have like a question and answer chatbot. And then for this vector database, you have more open source like Qdran vector database, FAIST databases, things like this. And then how do you select the best out of large set of services that are around? And also you have a lot of models like ChatGPT, GPT-4o, Bedrock models, so which one would be the best, right? So there is no standard protocol that every AI developer can use. That's why the idea was from the open community that they bring in something standard, and that is known as MCP, to have like increasing application complexity to reduce it, because then there is more collaboration between AI engineers. And then there would be less authentication methods, and then everyone would follow some kind of standard procedures to address issues like security concerns, having like more APIs integrated to their use cases as well. So there comes MCP, the missing standard for the AI integration. So multiple AI developers can now collaborate together with speaking the same language. Then it's more better for the AI as well. So as you know, with the web development, there's a standard protocol already, which is known as REST API. But however, now for the MCP, for the AI, it's now MCP. So now it could address issues like, for example, now I want to create a service, like chat with your database. AI developer in another company writes his own tools, and I, at my company, would write a different tool. But now if we use MCP together, we both speak the same language, and the code standard would be looking similar. And then now there is a lot of reuse in the community. So that's why we need MCP to have a standard protocol in developing AI applications. So moving further, this is how an MCP server would look like. So as there's always a server and there's always a client, and client is something that you would use as a user. So it's a user interface. It can be cloud desktop, which is open source. It can be your Visual Studio Code, it can be your GitHub, it can also be a Streamlit application or a Django application or a Flask application. That is what a client means. And then now we create MCP servers. The MCP servers always have tools, resources, and prompts. These are coming by default. So if anyone wants to contribute to the open community and create an MCP server, he should first introduce tools, resources, and prompts. What does resources means? That means, for example, you are creating a database, and then that is one of the resources that you would add to your MCP server. And then what does tool means? How would you do a calculation inside your database, a SQL integration or things like this? So that would be considered as a tool, and then specific prompts related to your MCP server. And then now, if I want to publish this MCP server, I have a standard format to write it, and then I publish it. Anyone from the open community can use this MCP server and then integrate into his Visual Studio IDE or a cloud desktop or his Django application, because it's quite reusable. That's the concept of MCP server. You always have a common language that you can speak between different developers. In the core architecture, this is how it looks like. As you see on the MCP server, you always have resources, tools, and context and prompts. And then in the protocol layer, it automatically converts into a JSON RPC 2.0, and then it is passed to the client as well. So if you want to really use MCP, there is a lot of topics, but the main part is you need to understand MCP client. As mentioned, the client is always with respect to the UI. So in the UI, it depends however you want to configure the client. For example, for a chatbot, you definitely need to have like a session history so that the chatbot is aware about the session conversation, what is happening around. And then you also need to configure your MCP server. It could be one MCP server or it can be multiple. That really depends upon how you configure the client. And then also with respect to how you handle if there is any connection issues to the MCP server. So these all would be included in your client side, and client is quite changeable. What does not change is basically the MCP server, because there is a standard of writing it, and we already discussed what contains in an MCP server is tools, resources, and prompts. For example, tools can be retrieve and search from your PDF document, or it could be just a tool to send an email and an Outlook. So tools can vary. And another tool which we spoke about already is like a database. So multiple tools, it depends on how many tools that you want to add inside the MCP server. It could be just one tool, or it could be like several tools together stacked into your MCP server. And then you also have resources, basically means what data that you want to process in this MCP server, and then what you want the user writing the client function to access inside this MCP server. And obviously the prompts, so you could have different prompts for different tools, meaning it would increase the accuracy, because as you know, the prompt engineering job is the best job that you can do right now, because everyone can write an AI agent, but it does not really work in a real use case because the prompt has to be better. And once, for example, you would invest time in 8 hours in developing an AI agent, but your prompt is not nice, in the end, it would not work. But someone would come and fix just your prompt, and then it would say it works better. But then he would get the credit. So prompt engineering is the best job, so you need to be aware about different agents and different tools and respective prompts. So that's why they also have this inside the MCP server, because prompt is also considered very crucial in AI applications. And how did evolution of MCP transport types happen is like the first it started with an STDIO. What does that mean? Standard input output, more useful for your local development practices. But when you want to have with HTTPE, then it becomes much more complex. Or you could also have like streaming options with HTTP, and then you have to deploy it on a cloud environment, which definitely comes up with a cost. But if you just want to showcase or want to try out MCP, they also have other protocols of communicating, and then that could be done with an open source community. So how easy are MCPs to set up? It's very easy. So as you see, there is already growing MCP support. So they have like more than 50 or 100 plus open source community already contributed to the MCP servers. There is a list of reference servers that is already here. For example, let's take an example of Google Maps or PostgreSQL database. So you could just download this Docker image or an MCP server from this open source, and then get inside your VS Code or JetBrains, whatever you use at your industry, and then you can also integrate to GitHub and things like this. So it's quite easy to integrate because it's already available, and then a lot of effort is done by an AI developer and then publishing it. All you need to do is just download the Docker image and then have like a JSON file inside your VS Code or JetBrains, and then you're ready to use a SQL server. Because to develop, for example, chat with your database, it takes months together or quarters together in your planning. But when you already have an AI developer which already published it, you could just reuse it. So that's the main advantage of MCP server, because everyone is using the same language, so there's a lot of reusability that comes up with an MCP server. And then, for example, now you saw a lot of open, publicly available MCP servers, but however, in your department or in your industry, you cannot use it because obviously there's compliance and governance. So you cannot just take someone else's MCP server and then use it in your environment because it might be a compliance risk. So sometimes what people also do is that they build an MCP server on their own. And for example, we already spoke about what is inside an MCP server. That is, first thing is tools. Tools are mainly what is required over here, like a calculator, but there is a specific type or a decorator that you use before you actually have tools inside your MCP server. So before, every AI developer thinks he's the best at the data structure and then had to create his own Python function, one-line Python function or a two-line Python function. Now everyone is using the same decorator, so everyone follows the same protocol. So you could just reuse the list of tools. What it basically means, if anyone is using your MCP server with it just this decorator, he would be able to get all the tools that you are defined inside your MCP server. And there is also tools handler. So for example, when there is an error in your tool, so you should also have like a handler for your tool so that if something goes wrong, there is some response going back. And this is how you would look like once you have your tools with descriptions. So anyone want to use your tools, you could just use this MCP server inside it. And this is how they could call the tool server. This is more related to the code, so I would just skip it. And this is more about prompts, another important concept inside the MCP server, which I told you about. So there could be multiple prompts for your multiple tools. So there is a way of having at all one place. That is known as list prompts. So you would have multiple prompts for multiple tools stacked together. And then based on what the prompt that you want, you could just call it, because they also provide another decorator, another method function to just reuse whatever the specific prompt that you're looking for. And this is how it would look like with different prompts and different arguments. And this is how you would also call it. So it's more structured. And now it's time to deploy your MCP. Now that you know that you would want to create your own MCP server with tools, prompts, and resources that you want to give access to the MCP server, you could deploy it into 2 cloud providers, definitely. One would be on the AWS. Is basically you would have to Dockerize your MCP server inside a ECS or a EKS or a Lambda, or you could also do it on a Fargate if you want to make it serverless. And then all you need is a user in the load balancer hitting the API first, because then you would have HTTPS. But you could also add in like Route 53 to have like a specific DNS name for your MCP server. And then your client is running on also an EC2, and your server is also running on an EC2, so you have one common DNS, and the user could be using it in a Streamlit or another Angular UI and things like this. And on the background, the MCP server is contacting your APIs, which could be any data sources. So this is how it's easy also, because the cloud providers also provide you like the specific GitHub deployments, which is already ready to use. So it's not much of an effort to deploy it on cloud providers. And then now if you want to deploy it on an Azure, you just replace the API gateway with an API management. So similarly way, you would Dockerize your MCP server, but rather you would use a Azure function or a dynamic apps to Dockerize your MCP server, and then you could provide as an API to different UI use cases. It can be VS Code or anything. And then definitely you need a authentication for your MCP server, which is the most important. So you would always include some kind of a Microsoft Entra ID or a different authentication respective your industry standards to have like a security layer on top of your MCP server that you're going to publish. So let's take a simple problem with a Tableau problem. So here, if you see, as I mentioned over here, the cloud desktop is an open source. So the user is now using a Tableau server, which has a lot of tools and which has a lot of prompts specific to it. And then now from the UI of the cloud desktop, he wants to get something done with the MCP server. And then now he asks a question to the client, and the client decides which tools to use. And the tool one would then communicate back to the client saying, this is the tool that you have to use for this particular user query, and then gets the response back. But if the client thinks I need more information about the Tableau, what the data looks like, then it would automatically contact another tool to get more information. So as you see, it's more about to and fro until the user gets the perfect, accurate answer. So it's more like an agentic AI that you can construct out of an MCP server. So we discussed a lot about MCP server by Anthropic, but there's also another protocol which is agent to agent by Google, so which looks quite similar to MCP, but not really. It is an MCP. So let's try to discover why and how to use A2A along with MCP so that you have a more robust application. So what is A2A about? It's also an agent-to-agent protocol. There in the MCP, you're more focused on creating a server, but here in the agent-to-agent protocol, you're more focused on creating an agent. So what does an agent mean? So just consider ChatGPT. So it's just an LLM model. But now the ChatGPT, you give more power to it. For example, it could calculate something like what's the distance between Earth and Mars, and what's the distance between Munich and Frankfurt. So it could calculate distances. So that's the power that you give to your agent. And then another agent is specifically handling more with respect to location or more with respect to Google Maps. So you have multiple agents and multiple powers, but there is a need of these agents to communicate between each other, and that's where A2A protocol comes into place. So you can build your agent with respect to using LangGraph, which is another open source, or you could build an agent with a different LLM provider, Llama, using Crew AI. You can also build another agent with another parameters, but the advantage now with A2A protocol is all these three agents can communicate with the same language, which is A2A. So just to summarize, A2A is more related to agents. MCP server is more related to having a standard protocol and building servers for reusability. So how does an agent talk to another agent? So basically, there is always an orchestration agent which does an agent discovery. So every agent now has to be defined, saying with an agent.json what it can perform. So basically, every agent has a CV on its own, and a supervisor agent gets all the CV of the different agents available using agents.json that is defined by different agents. And then now the supervisor agents knows what's the powerful or what skill set the other agents has. So that's the advantage with just one JSON file. You have a multiple agents communicating against each other, which increases the robustness of the AI applications. Here, let's take an example. So there's an orchestration agent, which I talked to you about, and there is 4 different agents. So HR agent, IT agent, facility agent, and a hiring manager agent. And then here the task is the orchestration agent handles a person who's joining into a company onboarding process. So you have multiple agents doing multiple tasks. As mentioned, the orchestration agents with the agent.json reads what HR agent does, what IT agent does, and what facility agent does. And based on the user query, it communicates between different agents. And then once the task is done, then it reports back to the hiring manager that this user in this company now is onboarded. As you can see, now multiple agents can communicate against each other and then have more of a different task accomplished with different skill set that is required for the orchestration agent for a particular use case. So how do we now integrate with this with MCP? Is basically we spoke about different MCP servers that you can define about, But now with agentic AI, you would always have for any GenAI application multiple agents, because with one agent you cannot solve much. So each agent can then be attached to MCP server, and then another agent with another MCP server, and these agents then communicate with A2A protocol. So it looks a bit complex, but in the event it's quite easy. So this is how it looks like. So now I would create an agent with different MCP clients, different MCP servers, and another agent with a different MCP client and a different server. For example, the first one can be a Redshift database, and the second one could be an Oracle database. And then you have two different agents with two different MCP servers connected, and these agents then communicate with A2A protocol. As you can see, you could do a lot of things with this MCP server and A2A combined together, rather than discussing which one is better, but it's always nice to have both on the place, because both has different advantages and disadvantages. So this is how you can combine A2A and MCP together. And that's it. I would like to keep it short.